Welcome to the Introduction to ml-gradle tutorial from MarkLogic University. To follow along with this tutorial, you'll need to download the CentOS/Red Hat version of the MarkLogic installer. You must also have installed a recent version of Docker, the Community Edition, Java, Gradle, and ml-gradle. Note the tested environments in the README file that's part of the tutorial files. Download the tutorial files and follow installation instructions in the tutorial README by going to github.com/marklogicuniversity/on-demand/ml-gradle-tutorial. In this video, you will learn what is Gradle and what is the ml-gradle plugin, and do a hands-on demonstration of using Gradle and the ml-gradle plugin to create a 3-node MarkLogic cluster using Docker. Then configure a MarkLogic application server and associated MarkLogic databases, complete with forced replication for high availability. Gradle is a popular open-source multi-project build automation system that builds upon the concepts of Apache's Maven and Ant. Gradle has a rich API and a mature plugin ecosystem to build and deploy software on a wide variety of platforms. ml-gradle is a Gradle plugin to automate deployment and configuring MarkLogic systems and applications. ml-gradle targets applications that use MarkLogic's REST API, such as Java and Node.js applications, but not limited to these. ml-gradle utilizes the Management REST API in MarkLogic 8 and higher to configure and deploy all aspects of an application. Can watch for new and or modified modules and automatically load them for you, thus speeding up the code, build, and test cycle. Can run content pump, corb, and other Java-based MarkLogic tools without having to copy jars around and worry about Java class paths. Can treat packages of MarkLogic code as true third-party dependencies, resolving them just like you would a dependency on a jar, as well as automatically loading such code into your module's databases, and can take advantage of all the other features of Gradle. In this tutorial hands-on, we're going to deploy a MarkLogic configuration to support a theoretical application's requirements. For the purpose of this tutorial, we will assume we are beginning development of a 3-tier application, using a browser-based user tier, a Java middle tier, and MarkLogic as the database tier. Our application will use MarkLogic's Java Client API to communicate with MarkLogic databases. The architecture will need to support high availability for our content data, and Gradle is our deployment tool of choice. To support our tutorial requirements, we will need to do the following. 3 MarkLogic servers will be needed, which is the smallest cluster that supports high availability. One of these MarkLogic servers we'll call MLS Node 1, will be a combination E and D node on which we'll create a MarkLogic REST instance application server and our content and module databases. The MarkLogic Java Client API communicates with MarkLogic via the REST API. The other 2 MarkLogic servers we'll label MLS Node 2 and MLS Node 3 will be D nodes to support our storage and also replica force for high availability. Our deployment supports the desired architecture. The MarkLogic server, MLS Node 1, has our REST API instance, a configuration of MarkLogic's enhanced HTTP server. The content and module databases will also be defined on this MarkLogic server. The combination E and D node architecture will support our REST connection to our Java middle tier and also permit redundancy for high availability if needed. Force for content and module databases will also be created on this MarkLogic server. The MarkLogic servers MLS Node 2 and MLS Node 3 expands our data storage for our databases. The force on one MarkLogic server replicate to force on other MarkLogic servers to support our high availability goals. The demo will show the following. A Gradle project that used the ml-gradle plugin to deploy this project. To configure this project, we will normally need MarkLogic installed on 3 different servers, creating a 3-node cluster. Since we're deploying this to a single computer for the purposes of learning, we will use Docker to create 3 Docker containers. Each Docker container installs MarkLogic. Gradle will initialize each MarkLogic install, plus create a MarkLogic administrator account on each of the MarkLogic Docker containers. Let's get started. We have some software dependencies to resolve before actually using ml-gradle. First, let's check that Java is installed and working. Java 7 and higher is required, but it's recommended to use Java 8. In a command line or terminal window, type java -version, and then press enter to double check your Java version. Another requirement is to install a current version of Gradle. In a command line or terminal window, type Gradle -version. We're going to use Docker to create our 3-node MarkLogic cluster. Verify that you have a recent version, 17.03 or greater, of the Community Edition of Docker installed and working. In the command line or terminal window, type docker -version, then press enter to verify the Docker version. Download the ml-gradle tutorial files from MarkLogic University's GitHub repository at github.com/MarkLogic University. In the on-demand section, download ml-gradle-tutorial. Finally, for Docker to create each of the MarkLogic Docker container nodes, you'll need the Red Hat Enterprise Linux /CentOS version 7 installer for MarkLogic 9. You can download the MarkLogic installer from developer.marklogic.com/products. After downloading the MarkLogic.rpm installer and also downloading the ml-gradle-tutorial project, copy the .rpm installer to the Docker subdirectory within the main ml-gradle-tutorial directory. In the Docker directory, edit the Dockerfile script. Ensure the .rpm file name referenced in line 18 is the same as the file name of the downloaded MarkLogic.rpm installer. If not, change the name in line 18 of the Docker file. Leave the second file name as /temp/marklogic.rpm. Save the Docker file if you made changes. Recall our desired architecture. To create a 3-node MarkLogic cluster, we'll use Docker's Compose tool to create 3 Docker containers. Docker Subnet handles the network communication between each of the Docker containers. MarkLogic uses port 8001 for the administrative interface and port 8000 for query console. Each Docker container exposes these ports outside the container by mapping them to available ports on the host computer, running the Docker engine. We will use the following port mappings to communicate with MarkLogic within each container. Container 1, with a host name of MLS node 1, will map the container's MarkLogic's ports 8001 and 8000 to the host computer's ports of 8001 and 8000. If you have MarkLogic already running on your host computer, you will need to stop the MarkLogic service before continuing to avoid port conflicts. There is no need to uninstall MarkLogic, just stopping the MarkLogic server will avoid any conflicts. Container 2, with a host name of MLS node 2, will map the container's MarkLogic's port 8001 and 8000 to the host computer's ports of 18001 and 18000. Finally, Container 3, with a host name of MLS node 3, will map the container's MarkLogic's ports 8001 and 8000 to the host computer's ports of 28001 and 28000. Gradle is organized into a main directory and possibly subdirectories. Gradle refers to each directory as a project. Tasks are added to build.gradle files in each directory that will have specific actions. Each Gradle project directory can store extra data formatted as property value pairs within Gradle.properties files. The build.gradle scripts then access the data values by their property names. Let's take a closer look at these. The main project's build.gradle file, located in the ml-gradle tutorial directory, extends the standard Gradle functionality by adding the ml-gradle plugin. If the plugin is not local, it will be downloaded over the internet. The build.gradle also defines a default task called deploy app. If Gradle is started from a directory without a specific task, Gradle will look for a default task. If no default task is given, an error is returned. The two main tasks control what this build.gradle file will accomplish. The deploy app task controls the order of the tasks necessary to accomplish our overall project. This task will create a Docker cluster of 3 Docker containers. Each Docker container will have MarkLogic installed. The deploy app task also calls other tasks to initialize MarkLogic in each of the 3 Docker containers. Create a user with the admin role, then join all 3 MarkLogic servers together into a MarkLogic cluster. Finally, the ml-gradle task of ml-deploy creates our project REST API app server, content, module, and trigger databases. Forest to store data, and replica forest for each of the content forests. The cleanup task tears down our MarkLogic cluster, deletes the MarkLogic items created in the deploy app task, and also deletes the MarkLogic containers and Docker cluster. The initialize, create admin account, add nodes to cluster tasks assist with the main deploy app task to ensure any steps dependent on other steps are done in the correct order. ml-gradle uses properties for configuration settings. The gradle.properties file located in the ml-gradle-tutorial directory define the following ml-gradle property values. ml-appname is the name of the REST API server to be created for our application project. ml-host and host are the host names for the MarkLogic server. Since Docker containers use the host computer's networking, the only host name needed is localhost. ml-rest port is the desired port on which the newly created REST API server listens. ml-admin port and ml-manage port are the port numbers MarkLogic uses for the administrative interface and the manage application server, respectively. Most of MarkLogic's REST APIs use the MarkLogic manage port. ML username and ML password are the username and password to be created for the administrator role. This user will have the admin role and is required to be created after MarkLogic is installed. ml-gradle has tasks for initializing MarkLogic and creating an administrator account. ml content forest per host specifies the number of forests per host when a content database is created. ML database name and replica count is a comma delimited string of database names and forest replica counts. The ml-gradle property is useful for when you want to configure failover for a database and you don't need to specify any configuration for the forest replicas other than how many you want for each database. The build.gradle file in the Gradle Docker subproject, located in the Docker subdirectory, contains several tasks related to calling Docker and the Docker Compose tool. The create cluster task is called from within the main project's deploy app task. This task runs Docker's Compose tool, creating 3 Docker containers. Each of the Docker containers installs MarkLogic and then starts the MarkLogic service. The teardown cluster task deletes the 3 Docker containers. The Docker image that was used to create the containers will remain. The add nodes task runs the docker exec command to run a shell script inside of each Docker container. The shell script uses MarkLogic's REST API to join the 3 MarkLogic servers into a cluster. The Docker subproject directory also contains a gradle.properties file. There is only one property called Docker nodes, which has a value of a comma-separated list of Docker container host names. These names were created in the Docker Compose Tools YAML script and should not be changed. 3 build.gradle files in separate subproject directories run ml-gradle tasks that initialize MarkLogic and create an administrator account in each Docker container. The ml-gradle task, ml-init, initializes MarkLogic after installation. Initialization creates application servers, databases, and configuration necessary for MarkLogic, and is a normal step in the installation process. The ml-gradle task, ml-install-admin, creates an administrator account in MarkLogic. This task uses the values of the ml-gradle properties of ml-username and ml-password to create the account. In our project, these are defined in the gradle.properties file located in the main project directory. The build.gradle files in subprojects inherit these main properties. The main Gradle deploy app task ensures this is done before the MarkLogic servers are joined in a cluster and before any other configuration changes in MarkLogic. The gradle.properties files in the 3 MLS node subdirectories contain the value of the MarkLogic administrative interface and manage app server ports. The values are ports on the host computer mapped to ports in each Docker container. The mapping was done with the Docker Compose Tools YAML file and should not be changed to successfully run this hands-on tutorial. The ml-gradle plugin applies a number of defaults out of the box. These may be just what you are seeking to accomplish for your MarkLogic application deployment, but most likely you will want to customize your deployment. Properties such as application server name and port, content database names, etc. can be set to override default values without needing to create configuration files. Since ml-gradle uses MarkLogic's management REST API, the full breadth of configuration is available to use. The payloads for these are documented in the MarkLogic documentation for the management REST API. Any customized REST API payloads ml-gradle sends are defined by files you create under source/main/ml-config, the default configuration directory. Each of the subfolders under source, main, ml-config maps to a configuration item. The MarkLogic Management REST API documentation lists the properties supported by each item, for example, databases. Configuration can be stored in JSON or XML format. In this tutorial, we are configuring the following items: a REST application server using the JSON configuration file rest-api.json, and a MarkLogic content database using the JSON configuration file content-database.json located in the databases subdirectory. Let's take a closer look at these configuration files. The rest-api.json file, located in the source, main, ml-config directory, creates our REST application server for desired application architecture discussed earlier. The values that begin and end in double % signs are called ml-gradle tokens. These values will be filled in according to ml-gradle properties that were set in the gradle.properties file. For example, the name of our created application server will be the value of the ml-appname property, which, in the gradle.properties file, is set to mlu-gradle-demo. The port number will be set to the value of the ml-rest port property in the gradle.properties file, which was set to 8003. We're going to override any default content database name by specifying it in the content-database.json file in the databases subdirectory under source, main, ml-config. In the gradle.properties file, we have a value called ml database name and replica count, which defines the database name as mlu-demo-gradle-content. On a command line or terminal prompt, change to your project's main directory that has a build.gradle file. Then type the Gradle command followed by the name of the task or tasks to run and press enter. For our project, ensure you are in the main project directory of ml-gradle-tutorial. This is the directory where our main build.gradle file is located. Type Gradle space deploy app and then press enter. Gradle will download the ml-gradle plugin if not already present. Then Gradle will begin performing the deploy app task, including sub-project tasks such as creating the Docker cluster, then calling the ml-gradle plugin to initialize MarkLogic in each of the Docker containers, creating a MarkLogic cluster, and then using the ml-gradle plugin task to deploy our application configuration. In a browser, go to the URL of http://localhost:8001. Log into MarkLogic with the administrator username of admin and the password of also admin. Remember, the administrator username and password was created as part of our ml-gradle deployment task, and the values controlled by the ml-gradle properties of ml username and ml password in the gradle.properties file. The admin interface shows our application server deployed on port 8003. Content, module, and trigger databases were created along with forests. Replica forests for our content database were created to support our project goal of high availability. When you want to remove what was created by the deploy app task, a Gradle cleanup task was defined in the build.gradle file. Make sure you are in the main ml-gradle-tutorial directory, then type Gradle space cleanup, then press enter. The application configuration will be undeployed from MarkLogic into 3 Docker containers, then the Docker containers will be stopped and deleted. Learn more by visiting the ml-gradle repository at github.com/marklogic-community/ml-gradle. To visit the ml-gradle wiki, either click the wiki link at the top of the repository page or go directly to the wiki at github.com/marklogic-community/ml-gradle/wiki. Get an overview of ml-gradle at the ml-gradle Getting Started Guide in the ml-gradle wiki. The ml-gradle repository has many examples to download and try. Learn more about the Gradle build tool with the Gradle user guide at https://docs.gradle.org/current/user-guide/user-guide.html. In this episode, you learned what is Gradle, what is the ml-gradle plugin for Gradle. To get MarkLogic, download from developer.marklogic.com. The examples from this episode are available from MarkLogic's GitHub repository at github.com/marklogicuniversity. Get more training by visiting marklogic.com/training. Also, a complete selection of on-demand topics is available at mlu.marklogic.com/ondemand. Or download the MarkLogic mobile app, available on both Apple App Store and Google Play. And don't forget, show off what you learned. Add MarkLogic as a skill to your LinkedIn profile today. Thank you for watching this MarkLogic University on-demand tutorial.